Hello my audience. In this video we will finally get started with the project. In this video I'll explain the WebUI and show how message passing can be done between the frontend and the backend. Going into this video, I admit I wasn't sure exactly how something like an UI could be explained. I spent some time thinking about it, and then I had a realization. Mathematicians have theorems and proofs, but programmers have goals and programs. So all I have to do is show that the program matches the goal I set out to do. And a particular goal I can just draw out first in Excel draw here. An alternative to this would be to just program the UI from scratch and do a screen recording of that, but that would take too long. I doubt that anybody wants to spend an hour watching me do basic HTML programming. So in this course, I'll adopt the presentation format of sketching out the program in Excel draw and then align that in your mind with the finished program. Since we are doing a heads-up poker UI, let's start with a big box to signify the window. Then I'll need the elements to signify the cards on the table. The LIDAC game has 3 different possible actions: fold, call and raise. So I'll need buttons for those. Next, I'll need the player to actually see what the cards are on the table, so let me put in some text to signify that. We'll also need something to show how much has been bet into the pot already. This is pretty good. It is good enough for a minimal UI. One other thing we'd want is something like a text window, something to show the game history. This is pretty good to start with. You can do a lot with a text box and some buttons. Anyway, I've already done this UI, so let me demo it here and show you its internals. Right now the game isn't implemented, but if I click on the buttons, that event is sent to the server and it replies with the action history. If you go into the Chrome DevTools, you'll see that the entire UI is split into segments. At the outermost level, it is split into the game and the chat UI. At the outer level, into the top, middle and bottom. I've marked the containers with the relevant class names for easier understanding. You can see how in the HTML hierarchy the top only has a card, while the middle has a card and a pot size element. The bottom has a card and a few buttons. Each of the lines in the chat window is a paragraph HTML element. I made the margin too big here. Now let me show you the code that actually creates this view. I'm using the Feelings library to construct React elements in the view here. It has a strong resemblance to regular HTML, but with the added benefit of being able to use the full power of a high-level functional programming language to write it. This F# code will compile to JavaScript on the client side, and if you are familiar with React, you should be familiar with this form of index.html. The index.html file links to this CSS file where the layouting is done. All the HTML classes are here. In the previous video, I said that HTML and CSS knowledge is mandatory because I won't be explaining how HTML and CSS work in this course. Instead, what I really want to do is show just what you can do with the ability to pass messages between different systems. Let us focus on that middle segment for now. Forget about the UI for a moment. When you click on a button, the WebUI sends a message to the server. And in this particular program, the server just bounces it back. The goal of this is to essentially write what is a Hello World WebSocket program. I wanted to set up the project and have confirmed that it works. In order to be effective as a programmer here, I do not need to know the details of how messages are passed under the hood or how the WebSocket protocol works at a low level. Instead, I just need this basic ability, and with it I can create any kind of application imaginable. And that on its own is worth getting excited about. Going back to the code itself, take a look at this button. Whenever the user clicks on a button in the UI itself, under the code it uses the dispatch function to set a message to the update one. That is this one here. It gets the clicked on message from the UI and over the bridge it routes it to the server. Later it gets a message back and it updates its model. The model for this English program is just a record with a list of strings here. Let me illustrate it. I'll explain briefly how the Elmish pattern works. It is also known as the Model View Update pattern, MVU. It has a model which can be any kind of immutable record type. Its update function acts as a server. It holds the model and receives messages from either the client UI or the backend server. The view function, on the other hand, is what creates the UI elements before passing them to the React library under the hood. After the update function receives a message, it sends the updated model to the view function, which recreates the virtual DOM, which in the end results in the browser UI being updated. If there are any changes in the virtual DOM, the view function takes in the dispatch function as an argument. Whenever a button gets clicked, like in the program I've shown, the view uses that function to push messages to the update queue. It is an important distinction to make. The view doesn't call the update function directly. It just pushes the message into some queue. All of this is done on the front end. With Elm Bridge and WebSockets in particular, it can also send messages which are just F# union types automatically serialized and deserialized over the network card. In the program I'm shown, the serialization format is the ubiquitous JSON, but the library has support for custom serialization formats as well. Going back to the front end, I neglected to mention the init function. Since the initial model has to come from somewhere, the init function is the one to provide it. It just gets called when the Elmish program starts and does not play a role after that. All of this is pretty straightforward when drawn out like this. And I hope now that you have this goal in mind, you can go back to the program and see how it matches the sketch made here. The link to the code itself is in the video description if you are interested in running it locally. Now let me just show you how the server is implemented and then we will be done. The backend server itself uses the MVU pattern except without a view. Since the backend server needs to be able to attend to multiple clients, it takes in the client dispatch function as an argument. The client, on the other hand, only connects to a single server, so it doesn't need it. Everything is in working order. I hope that what I've been explaining makes sense. This covers the equivalent of a Hello World program with Elm Bridge. If you like this video, please click that like button and subscribe. In the next video we'll do something fun, which is to implement a poker game, so stay tuned for that.